Okay, thank you for invitation. So today, in the next 30 minutes, I will um, try to answer a few questions about decentralized identity and decentralized reputation, why it is important, how it works, what are the principles, and give a few practical examples of how this will be implemented. To start with, I want to talk about the value of this technology and this concept, and kind of the market size, why we actually need it, what problem does it solve. So one of the key or the addressable market for decentralized identity, a large part of that is entities engaging in economic transactions. And today we have various options of various tools that allow us to solve for building trust and actually executing transactions and reducing transaction costs in the economy. So transaction costs are the costs between economic actors that arise and that are needed to establish trust, bargain, agree on the price, enforce contract execution, and police the deal. Today, we normally use a few systems for that, which is either government or personal trust, which already exists pre-built within the community because you belong to sort of community with a higher degree of affinity and trust. All of this is so the personal trust is not scalable just because you cannot know or you don't know most people who you're engaged in economic activity with. And the centralized trust systems are not very efficient because they try to solve this problem on a very large scale. These are usually governments or platforms that are building some kind of reputation or some kind of trust scoring for different entities. So for example, if we take an example of e-commerce, then there could be an online shop that has a rating which is either assigned by Amazon to a seller, or maybe they have some kind of certificate or license or I don't know, Trustpilot score. And that does not really ensure the trustworthiness. So you can, like, if you see a seller on Amazon, obviously you have less risk interacting with that seller. However, Amazon is not able to really very gradually quantify activity and represent the identity of that seller to the to the buyers, and also there's a large overhead when this function is executed by the government, because government is really optimizing towards the least common denominator. Government is not trying to build system that is like fully resilient or which is focusing on trying to distinguish between details. It is like large infrastructure for licensing, for different bureaucratic systems that are better than nothing, but in a lot of cases are very, very expensive way of solving this problem. So it is estimated that the global the global cost of building trust is about $20 trillion annually, and this is very rough estimation, obviously, which is a large portion of the global GDP, and it is obviously not all of that is solved by the single product. However, I want to talk about the approach, the technology that allows to us gradually start solving it for specific use cases, specific verticals. So as I said, in order to facilitate this economic activity and reduce the transaction costs, we need data. Data is how these transaction costs can be minimized. If we know something about previous activity, that can influence our game theoretic behavior when it comes to making an economic transaction. If I know that this platform, Amazon, I don't know, I made 10 purchases before, then I'm more likely to trust it and spend more money on it. If there's a doctor who has a government license, I know that at least they are allowed to do this kind of medical operation. Obviously, this doesn't solve the problem. This is not an ultimate solution. This is a solution that we have today. And this is a solution that the world is using, and not because they are optimal technologically, but because they're scalable. So our goal is to, if we can improve the level of efficiency, especially if we can improve it a few order of magnitudes, then I think adoption is just bound to happen. And this is what a lot of decentralized society components and principles are about. So let's talk about the actual examples and the process, how it works. So instead of so in self-sovereign identity or decentralized society, we have these three parties, which is holder. I use this image. Usually, I call it different names throughout the presentation. It could be economic agent or identity holder, but it's like this girl. And there's a verifier. There's someone who wants to know some information about myself to offer to provide me service. For example, if I go to a bank, they need to verify my ID. If I go to the doctor, they need to know my previous history of my medical history. If I go to an employer, they need to know my skills if I try to find a job. If I go to, I don't know, a website to buy something, they want to know what I like, my previous purchases, in order to personalize their storefront to me and make the offer more relevant. So what we want to get to is the world where me as an agent, as a holder, I can come to or within the economic interaction, whenever any information is requested from me, I have a single place, a single wallet, from which I can selectively share data which is relevant to the verifier. That's kind of the core, the nutshell. So instead of, and I have this next slide about it. So in today's world, pretty much all of our data, at least in digital form, resides with governments or platforms. So PayPal holds my transaction history, Amazon holds my shopping history, governments holds my identity information. And whenever somebody is requesting this information, I need to ask my personal information from the service that is the custodial of it today, get it, and then present it to the verifier. And this process can break in many options. So first of all, since I'm not holding my information, it can be changed, it can be altered, or it can be withheld. Actually, WhatsApp can block your access to your personal messages. And that sounds ridiculous, but this is how it works technically today. So if you're using Telegram or WhatsApp or Facebook Messenger or Viber or what have you, they are actually the ultimate custodial of your messages. It's their data, it's stored on their services. They are the holder of the private keys for that, for those messages. And they usually give you access to this information, but they can also give this access to somebody else, like governments, or they can withhold this access, close this access, or they can something can go wrong, or the service can be down. So whenever the Facebook service is down, you cannot access your WhatsApp messages. Unless they are stored on device or end-to-end encrypted, which is actually not true for majority of WhatsApp messages and Telegram messages as well. So all of them are stored on Telegram server. Otherwise, you won't be able to access the same message exchange from different devices. And the Web3 approach to solve this same problem is when all these services are writing data to some data storage that I control. Ideally, this should be a decentralized, user encrypted data storage, and the only thing that user has to do is to be custodial for their own private key, which is no different from cryptocurrency. As long as you control the key, you control this data. And we have quite a lot of technologies about that help store this data decentrally, and could be IPFS or ceramic or Kepler or things like that. Decentralized web nodes is probably the most elegant or widespread or widely used solution, which is still in beta. It's still quite early, but yeah, we know. Bottom line is we know how to do it. So let's talk about a few principles. How do we build decentralized reputation or decentralized society? I think the important principle, just to set the stage for this, is reputation and identity information is very domain specific. If these are examples from Web3, but you can, instead of NFTs and DAOs, you can think about your healthcare, your education, your family, your government financial information, your I don't know, gamer identity, your dating app identity, your creator identity, could be anything. So you have these domains which could interact, but they are kind of on the own, because most of the data within this domain makes sense only with only knowing what domain is coming from. So if we're talking about reputation for a DeFi user, what makes sense? What could be a and by the way, important, just to be clear, when I'm saying reputation, I'm not, at this point in presentation, I'm not talking about kind of trustworthiness. I'm just talking about data. Somebody has data. I have picture, I have text, I have some information, some on-chain transactions, some bank transactions. That is reputation. We're not talking about like how to judge if this data is correct or not yet. My DeFi identity can consist of a bunch of credentials, which is me being an investor, or I have a wallet, or I'm using a certain blockchain, or I have a certain wallet, certain number of trading volume, or I did a KYC. And then for each of these credentials, there should be always some source. So how do I trust this data? So this, for example, I can say that I repaid all my loans and I am the issuer of that information. So that's already enough, or that's already a valuable signal to think about, like, why should you trust this data? Because if it's just you claiming something about your financial activity, that has a certain degree of trust, which is associated with kind of your general reputation, or like, do I know this person? Why should I trust them? Probably not. In other cases, you can have an organization. Could be a government, could be a company, could be a platform, could be a network, an application that maybe issues some information. So Uniswap network can, in more or less trustless way, just looking at your on-chain transaction, issue, or actually not just them, but for the sake of example, they can issue you a credential that says that, okay, you traded more than $1 million in the last year using Uniswap, because all of that is transactions. They're coming from your wallet. They have cryptographic signature associated with that, and this claim is verifiable. So this claim can be audited, independently verified, And they might also act as a verifier because, for example, Uniswap might want to be interested if you passed a formal KYC, and this credential, which is a KYC credential, is issued by another party, maybe a bank or some identity verification agency. And that's kind of the basic flow. This is how any SSI system works. You have issuer who issues credentials, you have verifier, which in this case it's the same agent, or it could be two different companies who is asking you to present some data, and then you share this data with them. Then another principle, and also just an example of how actual SSI system works in practice, is data minimization. So with designing identities, the decentralized identity system, we want to come up with the design which is as trust minimized as possible. Ideally, we actually want to use ZK everywhere. And these are a few examples. So for example, I'm an identity holder. I have a credential which states this information about myself. It says what's my name, what's my shoe size, what's my age, and what's my citizenship. And then there's a bunch of verifiers who are interested in specific information. So for example, this guy only wants to know my shoe size. So it's a shop, it's an e-commerce shop. And for them, the only relevant part of my identity is what kind of footwear do I prefer. Nothing else is important. They don't care what's my name, where do I live, like what is my financial credit score. They only need to know that. So the SSI or DeSoc system should actually this kind of credential presentation should contain only the relevant information. This is called selective disclosure, and we will need this. So I'm just kind of defining some of these terms. Selective disclosure is when you select or only disclose part of an existing credential. Another option, which is even more privacy preserving, would be using zero knowledge proofs, which in this example could be I can generate a proof, a mathematical, basically just a number, which states that I am over 25 years old based on this credential. And obviously this credential down here below, it has a cryptographic signature and then kind of all the necessary information to generate these proofs. But based on this credential, I can generate a zero knowledge proof that says that I'm over 25 years old. Here's the proof. Anybody can verify it. Anybody can verify that this proof is in fact authentic. And I don't need to disclose what's my age. And that's the ideal scenario. And this is something that which is actually not possible today. So there's no way to do it without zero knowledge proof other than having a trusted intermediary. And that's what we use today. So today, there's somebody who, like, again, a government who verifies somehow checks your age, gives you a, I don't know, student card, and then you can use that student card to get access to some services that are only available to students. This technology actually replaces the need for that whole process altogether. Another important principle and property of self-sovereign identity or decentralized society system is the fact that users should ultimately have control over their identities. And that is already a strong, and that is very powerful statement, because what follows from this is that users also control how many identities they have and where do they use it. So there's no universal kind of identity. So how it really works. You have a metaphysical being, human being, which consists of kind of body and brain and maybe soul or some, I don't know, astral, whatever you define as a human being. There's a consciousness that has capacity to interact with the real world through human body, for example. Or maybe it's a AGI and completely evolved artificial intelligence that also can do the same, but I don't know if that exists. Maybe it does, and just doesn't want us to know it. But then the digital identity is not an actor, it's not a subject in itself. Digital identity is something that you control. And you can control and create multiple identities depending on the use case. So you can have an identity for gaming, in a game, which has nothing to do, or which has not a lot of similar characteristics with yourself, actually. So it could have a different name, different look, different. You use it for different cases. You can have a patient identity that you use specifically for healthcare. So it's like your medical history. And when you come to the doctor, you can give them this data and then, okay, so you had these problems in the past. This is what drugs do you take? This is what your, I don't know, what kind of medication was prescribed, what kind of activity do you do? And that is valuable, that is important information, that's critical information in order to provide a quality healthcare service. You can have financial identity, which is your credit score or transactions or anything related to kind of your financial life. And you can have identities that do not represent just you. You can have identities that are group identities, for example. So in this case, it's a DAO, or it could be any kind of organization, which is a single identity. It has a capacity to actually interact with the world, maybe sign contracts, engage in economic transactions, basically like an entity, like a legal entity, which is controlled by multiple people. So we have 1, 2, 3, 4 plus me, 5 multi-sig signers, and together collectively we are the controller of this identity. And this DAO, it is not like this cat. It is not there's no like single human being behind it. And it has nothing to do with like what drugs did I take last month. It has nothing to do with like what pistol did I buy from Counter-Strike, whatever. So it's identity. Basically, bottom line is identity is not just a person, and also identity is not just a human being or a group of human beings. Actually, identity could be a non-human computational agent. Smart contract has its own identity. It has its own reputation. It has its own capacity to engage in economic activities. It provides service to the customers. It actually makes money. It doesn't know how to spend this money, like smart contracts or blockchains or Bitcoin. It has no idea why does it want to become rich, because it's not programmed to be greedy or to spend money. But it has an identity, and that identity is very, very different from the identity of its creator. Because if you're talking about open source, there might be multiple contributors, people, like some person started the project and they gave up or lost interest. The project itself has identity, and as long as it's deployed on the blockchain as a smart contract, that identity persists and has capacity to interact with the world, and the world can interact with itself. And it's a little bit more predictable than people, because it will only do things that is actually defined in its code base. But if we're talking about AI, like imagine AI smart contract, then it could do unpredictable stuff. And that becomes even, it becomes even, at some point, it becomes indistinguishable from human identity. I'm not talking about Turing test, I'm talking about just like economic nature. So briefly, let's talk about reputation. So the difference between just a bunch of data point and reputation is that reputation is an insight built based on underlying data points. So for example, this is my identity wallet. I have my passport, my social security number, my concert ticket, but then some of these data points can be combined into a single reputation. So for example, all these 4 individual data points refer to my professional activity, and they can be combined into a single reputation of me as a management consultant. So all these data points have different issuers. Each of those issuers has some level of trust. None of them can be 100% absolutely trusted. All these data points have different kind of data, and but if we combine all of those, and imagine if not, it's not 4, but it's like 40,000. So if I can record all my professional activity, every conference I spoke to, every person I interact, every project I completed, every company I worked with, every, I don't know, open source contribution I made, every Miro presentation that I did over, I don't know, 20 years, that actually gives a pretty good idea and pretty good understanding of my professional capacity and capabilities and competencies. And it's also quite hard. It's very expensive to fake, because you need to, like, imagine this stuff is anchored on the blockchain, so you need to spend 20 years worth of time, like it's very expensive, to just be able to get nothing. So there's no incentive to try to fake the system. So the reason we care about reputation, not just individual credentials, is because we want to achieve veracity of information. So authenticity of information is achieved by cryptography. So if I have an issuer and they have a public key, and as long as that private key is not compromised, then their signature on the credential proves the authenticity of data. Veracity, on the other hand, cannot be proven, cannot be deduced from the signature, or cannot be deduced by the issuer persona, because if it's a single entity, so that's basically why blockchain or Bitcoin exists, because centralized systems cannot be trusted, because however good intentions there are in the beginning, centralized systems always tend toward, or always trend towards what's the lightest definition for that? Basically, people will start exploiting them sooner or later. There's no way to defend it besides making system decentralized, which makes it less efficient but more resilient. And yeah, so you trade efficiency for resiliency. And that's the reason why decentralized anything exists, and decentralized society specifically. That's actually true for DeFi, for the DAOs, and then everything else. Reputation generally, actually, I think this is more or less, I don't know. I feel like this is, I tested this a lot, and it seems like this is the good definition. So if we want to build someone's reputation, we need to get it from multiple sources, because we want it decentralized. So we want some data that a person can tell about themselves. Again, depending on the use case, depending on the domain. Maybe in financial reputation, that is actually not relevant. But this is kind of all data that we have available. Something that you can tell about yourself, reason we need it, because there is data, there is important information that nobody knows about you. Like, nobody else can prove it because it was never public. Like, what is your interest? What is your aspiration? What do you dream about? What do you want? What do you like? What you don't like? What you value? What people do you want to, I don't know, talk to, or what business do you want to build, or what programming language do you know, or what programming language do you want to learn? Nobody can tell it about yourself. So that's an important integral piece of reputation. Actually, for most use cases, that's enough. That's all that is needed. Your preferences, something that only you know, and there's no need to kind of ask anyone else, because who cares and who knows. Another source for reputational data is data that can be issued by a authority. Like maybe you Like, for example, in the Uniswap example, blockchain is an authority. If I use Uniswap and then ask Ethereum blockchain or smart contract on a blockchain to mint me a badge that I've traded $1 million on Uniswap, that would be an authority. Yes, this data ultimately comes from a decentralized network, but there's a single issuer that tells me that yes, this is true, or no, this is not true. And I kind of need to trust it, or I need to do verification myself. Depends on the use case. In some cases, in this case, in the case of Uniswap, I can go and independently verify this data on Ethereum blockchain. In the case of, let's say, JP Morgan or NASDAQ, if they issue me a credential that I traded $1 million worth of stock on NASDAQ, I just have to trust them. I have no means of verifying this information. I mean, what I'm trying to say is if somebody presents me a credential saying that they traded $1 million worth of stock on NASDAQ, I can verify the signature. Yes, it's coming from NASDAQ. Is it true or not? I don't know. There's no way to know. And then the last kind of source of data is peer-to-peer credentials or reputes. This peer-to-peer data is something that can be created in a high affinity group of people. So if I have, I don't know, 50 people who I work with in a company, and we maybe give kudos each other based on projects that we complete or our work. So, for example, there's a product called 30 Birds, very, very interesting company and product. And what they built is a Slack bot that you can install in your organization. And it will prompt users to give gratitude to their colleagues. So everyone who you work with, you can send them a kudos or a praise saying that, thank you, you are great, you helped me with this project, or you, I don't know, I liked your, whatever, how you write a code, or I like your management style, or I like your vision, or thank you for organizing the call, or thank you for watering flowers in the office, whatever. And that activity slowly becomes more and more objective because it is created in the community. And community, actually individual actors, agents within that community act as reputational data source. And over time, this creates another source for this. Again, it's relevant in some domains, like what I was explaining here. So it is relevant for professional activity, because if you're judging somebody professional skills, you want to talk to people who they worked with. It is not relevant in DeFi or finance space, because as a bank, I don't care if your friends say that you are like a good payer, good borrower. I actually need information I can verify, because otherwise I will lose money. And everybody, like on LinkedIn, the problem is on LinkedIn, you can have these commendations for skills from other people, but nobody trusts this because like people can spam each other with these commendations, and they're not valuable. So I think this is the last point I wanted to make, is that reputation is always subjective. There's no way of making reputation objective. In most cases, you actually don't need reputation. You just need identity. But rich enough identity, I kind of define it as reputation. But the way to make the way to solve subjectivity. So today we have a single credit score agency that is assigning credit score to the borrowers. So it's a single company that tells every single bank how creditworthy are you. Like, should they trust with giving you a loan? And it works. So this company is Actually, there's more than one company, depending on which country, maybe a few. In United States, there's 3 major ones. And they solve a huge problem. So every bank is paying them, and they are kind of integral part of the modern financial ecosystem. But this is not how it has to be forever, because they are subjective. Like, they have their own internal model, internal algorithm, how do they score people, and they are not ultimate truths. They don't know all the data, and they actually, it's hard to verify like how and why do they use specific approach. I think the way to solve for reputation subjectivity is to build a marketplace where you have a competing scoring models, and then each one of these scoring models has its own reputation. So basically, imagine a system. DeFi might be a good example, where you have your data, individual credentials, that are being funneled into a set of scoring models. Each one of those outputs a credit score. And there could be 1,000, 10,000, 100,000 of these models, because they're just code. It's like anyone can write those. But over time, some of these models, same way as deep learning works, you can kind of feed it back and train it based on, could be AI or could be like manual training through a programmer. You can validate and you can ensure that results are, some of these models will just produce better results. And what is also important is you will always have people trying to game the system. So, okay, if I can get a high credit score, that means I can maybe borrow money and run away with the money, or something, some way of exploiting the system. Therefore, it is a constant run and catch game between people who are trying to make this reputation more or less objective, and people who try to game the system and exploit it for their personal benefit. And this is where the mechanism design comes in. Basically, the goal of designing the reputation system is to build a system where the cost of attack is always strictly more than the potential benefit of this. So I need to spend $1,000 in order to game or break the model, the system, the reputation system, which will get me at maximum $800 worth of kind of return or ROI. So I always, as an attacker, I constantly lose money. This is how Bitcoin consensus is based, or actually any kind of blockchain consensus is based on this rule. It is always more expensive to try and not obey the rules of the system. So like mine blocks which are invalid, or in proof of stake, depends on the proof of stake implementation, but there's certain things that you are not allowed to do, otherwise you're getting slashed. In proof of stake, you just lose your money. In proof of work, I think it's even better. You pay in entropy, you pay in energy, you pay in kilowatt hours, which is always a positive, which will be more expensive than your potential gain from this. So I ran a little bit longer, but this is kind of the key ideas I wanted to share. Thank you for your time. Thank you for listening.